guys are great at building prototypes, but moving prototypes into production requires good architectures. It requires good foundations. It requires good execution. Okay. And a lot of it comes from understanding, getting that background in that I've had, together with the new expertise, the deep expertise in applied AI and ML. Okay, so since my transition, I've been a fractional CTO. I built a graph neural network model, and we're going to look at graphs today as our topic, one of the topics. So I'll talk about some of the use cases beyond what we just discussed today, right? Because I see them in action, and they're very powerful. Like I mentioned, not today. I run my own consulting firm, KV Inc. AI. I'm a senior staff AI and ML systems architect, and over the 2 decades, I have multiple organizations. And too many to list. I've just summed it up in this slide. Okay, so that's it. That's about me in a nutshell. Let's get started on our topic today. Well, Gen AI is there for all. We've all seen the uses of Gen AI, right? And there's one thing that I would like to ask you folks before we start off. Have you interacted? What is your interaction with these Gen AI applications? What comes to the top of your mind? That's the first question that I would leave you with. While I'm waiting for the responses on that one, I'm going to introduce you to our agenda for today. I'm going to be talking about how to augment Gen AI applications, specifically those that are focused on search, right? How do we augment those capabilities with using knowledge graphs? I'll be talking a little bit about RAG, traditional RAG systems, their limitations, and why that hasn't been sufficient, which is why the move towards using perhaps knowledge graphs, right? There are multiple variations of to improve RAG. Knowledge graphs is one of them. Okay, and our focus today for this webinar is going to be how do we improve RAG with knowledge graphs, especially when they're used in Gen AI applications that involve search. Okay, so that is going to be the first part of it. The second part, going deeper, we're going to dive deep into knowledge graphs. What are they? What are some of the concepts that you need to be aware of? How does this help with retrieval augmented generation? And then we'll be talking about what are these graph RAG pipelines? How do they look in production? Because, like I said, my focus has been to move from beyond demos into production ready systems, focusing on what are the pipelines that we need to get it ready for production. And graph RAG is one such pipeline. Now, the third part, I'm going to be stressing a little bit about, again, production focused. What are some of the optimizations and best practices, especially when it comes to designing, architecting knowledge graphs, putting together that graph RAG pipeline. Okay, and then we'll have Rohan's quick intro into IK. IK's courses. I'll follow it up with a demo into the graph RAG pipeline. So you're going to see an actual application with the graph RAG pipeline in action, and you walk away with the pointer to the GitHub repo that you can explore in your own time. Real world applications, that would be the conclusion where I'll talk about the industry use cases, and I'll also talk about two of the use cases that I've leveraged it personally in. Okay, and then we'll conclude with the Q&A. All right, so now for the question. I did have that question that I posed to you folks. How do you folks interact with Gen AI applications today? Any
Dipti,
takers? Yeah,
Dipti,
please go ahead, Rohan.
can I interrupt you once? I'm so sorry. Folks are saying if you can get into the slideshow mode, if it's okay. They're finding trouble with
Sure.
slides. I'm so sorry. I didn't want to break your flow, but thought I'll
Oh, no
just
worries. I think I have the wrong screen shared. Sorry about
could
that,
be.
folks.
Thought
I'm
I'll
just
just
going to
put it.
reshare.
Put it up.
Yeah, thank you for that. 1 second, just give me. All right, I hope you're seeing my little whiteboard now. Sorry about that. I had the wrong screen shared, And thank you, Rohan, for pointing that out. Okay, so hopefully we are all functional. We are back to functioning. And this was a little power-packed agenda. Just doing a little recap because if you missed my little whiteboarding, it's in here. Okay, sorry about that. My question to you. Okay, I'm going to kick us off with that first question. How do you folks interact with Gen AI applications today in your day-to-day world? Any takers on that question? I'm going to look at the chat now. Please drop in your responses. Chatbot recommendations. Copilot, yes, yes. We definitely need those Copilot assistants in our coding, asking questions, Cursor AI, Gemini, answer engines, Copilot, a lot of Copilot users, document summary, Claude, building agents, Claude. Okay, I get the idea. Thank you, by the way, for these really engaging responses, right? Yes, the Gen AI has permeated our use cases today, specifically with chatbots. Chatbots like Claude, we have Claude, right? So we have chatbots, we have code assistants. I saw a lot of those Copilot mentioned there, right? We have code assistants, chatbots, ChatGPT, right? I'm going to use that as a very simple example of a chatbot. Okay, so when we think about ChatGPT, what comes to your mind? How do you interact with it? Um, are you talking, ChatGPT, by the way, is an example of an agent. But it literally is an agent which interfaces with a lot of models underneath it, right? So have you ever found yourself in a situation where you've asked ChatGPT a question and it hasn't been able to respond to you, or worse, it's hallucinated and it's provided you with incorrect data? Previous prompts, Mithil, thank you. Okay. But have you also run into the situation where it hasn't given you the right information, correct factual information, outdated data? Thank you, Sankal. That's what I was looking for, right? So here's my take on this, right? So when we think about chatbots, we as a user, we have prompts, right? We are providing prompts. This is your chatbot. I'm doing a little bit of a very rough visual here, but just to give you an idea, we have prompts. You have these fixed LLMs. Why do I call it fixed LLMs? Because it has static data that it has been trained on. Okay. And then it gives you a response. It gives you an output, right? And this is most often, if you're working with ChatGPT, this is a black box to you, right? But we all know and we agree that it's a snapshot in time that the model has been trained with, and hence the responses it provides could be outdated. It could be factually incorrect. Okay, so these are some of the limitations, very limitations that all of us are aware of, right? Nothing new. Hopefully, I'm not stating anything new. Okay, so now what happens? We enter the world of RAG, correct? What is RAG? Retrieval Augmented Generation. What does that do? It takes, all that it's doing is, there is a chatbot, again, the same model, chatbot. Okay, this is your LLM, which has fixed training data. It's working with fixed or static training data. Okay, and then with RAG, you're augmenting it with information from a knowledge source. This knowledge source could be hosted in multiple vector databases. I hope this is ringing a bell. Let me know if you need me to go into the specifics of what vector databases are. Happy to do that. Okay, and then once the prompt is then augmented with the information that is retrieved, right? This is retrieved context, right? So you have the retrieved context that's augmenting the query. It's augmenting the query, and then you get an output there is also a generator here, which is generating the output for your augmented query. Okay, the augmented query is nothing but your original query plus whatever was retrieved. Okay, and this is the context. And we are assuming that this has pulled in all relevant context that is needed to provide you with a response. Okay, great. Now RAG, we moved from this state, from static LLM interactions to working with a RAG. And of course, when you're working with ChatGPT, it's pretty transparent to you because everything that's happening here is a black box. We don't know what is it that it's interacting with. What are the different knowledge sources that it's interacting with? Right? And more often than not, it has more than one knowledge source that it's interacting with, okay? All right, so now we landed here. What do you think are the problems with this naive RAG implementation? Well, naive RAG, it does reduce hallucinations to a certain extent, okay? And it reduces hallucinations a bit. Let me just put it that way. It's a little bit, okay? And then it's also helping provide some correct responses. But remember, it's dependent on the context that is being pulled in as relevant. And when you're working with unstructured text, you're pulling in this context that is there is open to a lot of interpretations. Why? Because unstructured text can lead to a lot of interpretations. Okay, and hence you can get ambiguous responses. So while the hallucinations reduced a bit from this mode, we still have a few hallucinations. You could end up with ambiguous responses, mainly because we are working with unstructured text, which can have multiple interpretations, right? It's subjective in nature, correct? And what does this lead to? The response that you, as a user, the outcome focused, again, coming back to that, the outcome may or may not be satisfactory. It'll definitely be better than what you got here, right? It'll definitely be better than what you got here. But the outcome that you get here may or may not be what you expect. Okay? There's still hallucination. It's reduced, but not much. Okay, so how would you how would you improve this, right? So this is where we are headed towards generative AI applications that involve search, including agentic apps, right? I'll talk about agents very briefly, although it's not the context of our session today. But I want to introduce you to this so you know that the information that you walk off with today, is also useful for your agents. What are agents? This is your AI agent, right? And we know that an agent, it works with tools, it works with memory, it can work with reasoning and planning models. It can reason and plan. Okay, what are these tools? These tools are nothing but various forms of knowledge sources that you could be interacting with. Okay, and this RAG vector database is one of them, could be one of them. Okay, what if we could improve? What if we could improve the tools that an AI agent is working with? What if we could add, instead of just vector database kind of a RAG, what if we could add knowledge graph based RAGs? Okay, so remember this one, in this case, we are working with unstructured text as context, as relevant context. Okay, in case of knowledge graphs, what we are moving to, we are still going to do a retrieval augmented generation. You're working with structured data. Okay, what does that mean, right? So we'll talk about this very quickly here. So the takeaway from this particular slide is we started with LLMs, right? We said, okay, that wasn't enough in our search, especially Gen AI applications that involve search. We needed more. We went to RAG. And now I'm saying that we can improve RAG which works with vector databases and unstructured text with a knowledge graph based RAG. Okay, how does that work? Now, AI chatbots, assistants, recommendation systems, they're all wide applications of RAG, right? Including, like I mentioned, in the AI agent world, it's interaction with the tools. Where did I draw that? I missed it. There we go. Here we go. One of the tools could be a vector database, or you could be searching a knowledge graph. Okay, so hopefully this whole context, this breadth, is giving you a good overview as to why we're looking at knowledge graphs. All right. So I spoke about limitations of NaveRag. And very broadly, in my previous slide, I gave you this example that you're working with unstructured text, and hence that being open to multiple interpretations when you're providing that as context to your query, the query that gets augmented. Right? Now let's go in one level deeper. Let's figure out what exactly does that mean, right? So let's just say that you have this kind of a query. Okay, so what was the name given to the son of the man who defeated the usurper Electus? Do you think a pure RAG system working with a vector database could retrieve the correct information for you? Any takers there? What do you think? Do you think a pure vector-based search would help us answer this query? Well, yes, Sankalp, you're right, not without reasoning. Oleg, yes, we need graph search. You're preempting my next piece of what do you need, right? So here, what is good about this query? What is going on with this query? You will see that there are entities, Alectus being mentioned, right? This is your entity one, right? Then, or you can call it as subject, right? Then you have somebody defeated Alectus, right? X defeated Alectus. So this is your entity two, okay? And then you're asking, give me Y, where Y is son of X. Okay, so hopefully you're getting this view here that there are multiple hops that are going on. There are multiple hop reasoning that's going on in here. Okay, so in this kind of a query, just give me a minute. I seem to have enabled something on my whiteboard, and it stopped giving me the whiteboard controls. Just give me a minute. I pressed something in my decisions. Okay, I'm going to continue here. I might not be able to use the whiteboard much. Okay, I think I might be off. Okay. Sorry about that. Some technical difficulty here. I just lost my whiteboard controls. Just give me a minute. Just give me a minute. Sorry about that. Okay. All right. So I spoke about, thank you. I think I might be back in action and I might actually be able to use the whiteboard, but just hang in there. If I cannot, I might run into one or two minor difficulties here. Okay. So I mentioned this is a vector search RAG is it's likely not going to help us with this query. Okay. Why? Because there are a large number of entities involved in here together with relationships. Okay. A perfect scenario for what's called a knowledge graph, not representing this in case into a knowledge graph. Okay, I know someone asked me about talking a little bit about the pure RAG system, right? Let me see if I can draw this out. I want to go one more level deep, and I might not have this. Let me do one thing. I'm going to pull up a visual because I've lost my whiteboard connectivity. Uh, Whiteboard connectivity. Let's see if I can restore it because I had a lot of things that I wanted to help you visualize and draw. All right, so let's keep going. Looks like I've lost the little bit of my whiteboard controls. I have a little visual on just the RAG itself, right? So I'll see if I have this in the slides and continue through the slides, or maybe I'll get my presentation in here. Sorry about this. It's a little bit of a All right, I'm going to talk a little bit about the RAG itself, right? So here, in case of a RAG, we have a user asking a question, okay? This comes to a retriever. A retriever is talking to a knowledge base where it's performing a vector search. It can query and get the relevant documents, fetch the relevant documents. Those relevant documents is fed, it's used to augment the query. The augmented query serves as context that's fed into the LLM generator, and the LLM generator generates the response. Okay, this is pure RAG. And I couldn't draw this out to show you, give you that visual, but hopefully the sequence of steps instead are doing a decent job in getting the point across as to how the RAG itself would work. Here's another visual. Think of this as a RAG system, a plain RAG. Okay, so we start with a query. The query is embedded. What is happening with embedding? You're converting the text into a numeric representation with an embedding model, right? Because why? Computers don't understand text. We have to convert them into numbers, a numeric representation or the vector representation. And an embedding model gives us that representation. Now we store it, the query that's embedded together with other documents that are relevant would have vector representations created. They are stored into the vector database. Okay, now for a given query, the retriever is pulling in similar or relevant documents from this vector database. That is augmented into the query and it serves as context fed into the generator. This is a generator here. It's fed into the generating LLM to give you the final response. Okay, so this is RAG in its simplest, in its purest form. Okay, now when you throw in a graph RAG, what is a graph RAG? It has entities, nodes, and relationships. Consider a very simple example, right? Consider a very simple example. I see a lot of questions in the chat, not able to follow them and talk through it. So I'll come to the questions very quickly. Okay, just give me a few more minutes. In case of a graph RAG, we are working with facts, entities, and relationships. Okay. And when you think about entities and relationships, let's just say Paris is the capital of France. Let's say we have this kind of a text. Paris is the entity. It is a node. Okay. It's represented in a graph. Paris becomes your node, and the relationship. You have Paris here, node number one, France as your node number two. Okay, what is the relationship? France, capital, Paris, capital of. Okay, the relationship is capital of. Okay, so that is your graph RAG system where your nodes and your relationships are organized in a graph-like structure. Now, remember, when I spoke about using a vector DB with unstructured text, right? We were walking through putting in relevant documents. Okay. Now, when we put in relevant documents, we are not considering what is the relationship or is there any kind of interconnected data in the less relevant sections of the text that's there in the vector DB. However, with a knowledge graph, what we're trying to do is we are saying, hey, in the query, for the complex query that I introduced you to, who is the son of the man who defeated the usurper Alectus, right? Here we are extracting these entities and we are querying the graph. Now, it's not in case of a graph RAG, it's not a vector DB. It is a graph DB that we are querying with the node-like structure, the node and the relationships captured in a graph database to provide that context that is then used to augment the query and fed to the LLM and to give you the response. So what is the advantage of this, right? The advantage here is one, you're getting a holistic understanding. You're not just focusing on the relevant sections of the text. Okay, you're focusing on the extracting the structure from the text. Okay, so hence the LLM is enabled with a lot of structured information. Okay, so that is a holistic understanding. Second, I mentioned that with pure RAG, it has reduced hallucinations, but by a very little bit. Okay, in case of a graph RAG, just because these relationships are giving clarity, it's adding meaning, it's adding extra meaning to the query, the facts that are present in the query, right? There is reduced ambiguity and hence less hallucination than what you would get in a naive RAG implementation with a vector DB. Okay, and you get a comprehensive response. You're not just getting snippets, fragmented snippets of text that came in as relevant from your vector DB. You're actually getting, assume that in a graph RAG solution, you have a graph DB here, and the response that you're getting is going to be very structured based on the query that was there. Okay, so that is a very quick introduction into graph RAG. And Sankalp, yes, you're right. It depends on how the graph is built. Can you elaborate on how it is built and what it stores? Yes, in a few slides coming up shortly. I was just explaining the introduction. All right, so in a graph RAG pipeline, putting this together, you have the user query. This is driving the dual retrieval. You'll be retrieving not just from the vector DB, which was in the visual that you saw here. You'll also have a graph DB. We haven't spoken about constructing the graph DB just yet. I'm giving you the overview first. You're going to retrieve not just from the vector DB, but you're also going to retrieve structured information from the graph DB that is used as a retrieved context, which augments the query and it's fed into the LLM. Okay, so the steps remain the same. User query, dual retrieval, where you're combining both, you're retrieving data, you're retrieving the relevant documents from both the vector database, which is giving you unstructured and relevant text, and from the knowledge graph, which has structured facts. You're augmenting the query, so using that as context, and then feeding it into the LLM generator that produces your response. Hopefully the RAG pipeline, graph RAG pipeline is clear, at least from a top-down perspective. Now we'll start diving into what goes into the graph DB. All right, so the benefits, again, you have structured reasoning, right? Because there's multi-hop reasoning, you're extracting, you're looking at what are the entities in the query that you can support. The graph RAG supports multi-hop questions in the queries, okay? And the facts that are being retrieved are exact matches as well as graph connections. And we're combining the capabilities. That's the advantage that we are getting from graph RAG capabilities. I'll pause for questions here. I see a lot of hands raised. If you don't mind, I would love for you to engage, to drop your comments in the chat. We might not have time to cover all of it. Hence, I wouldn't unmute you folks if that's okay. If we have time at the end, happy to do so, right? Let me just pause for questions here. And let's just see. I'll be in transit control. Do we get the slides? Yes, we do. Carl Armour BM25 algorithm is a token prompt system used in queries, combines keyword and semantic search. Yes. Now, Carl, you are right in calling out the BM25 algorithm. So for folks that are curious about BM25, this is primarily a technique that's used in the traditional RAG system, right? Where instead of using vector DBs, BM25 relies solely on keyword matches. In case of vector DB, we are working with semantic similarity. We are using the embedding model to give us to embed either the query or the documents, the knowledge base of documents that we're going to store. It's extracting the semantic representations, okay? But BM25, on the other hand, it does what is it? It does a keyword-based search. And when you use in a traditional RAG system, you tend to mix BM25 together with the embedding algorithms, right? And if you're using LangChain, you'll see that there is a hybrid retriever where you can mix both these algorithms together to get the best of both worlds, right? But keep in mind that's very much specific to the vector databases where you're still working with unstructured text. Okay. So hopefully, Carl, that answered. Arun, chunking and then embedding. Yes. You would first chunk and then do the embedding. Of course, this was a broad overview. And when I do the code walkthrough, you will see that the chunking is done. And I had a question there. Why would you chunk? Right? So I'm going to preempt that question. Keep that in mind. Why would you chunk before the embedding? Okay. Balaji was asking, does RAG support type ahead search? Now, type ahead search is something that you would build in, right? Balaji, RAG is pretty much you're augmenting the capabilities of the LLM because LLM has static training data. In terms of providing type ahead search, that's coming in from a traditional search, Google-based search, right? You type in, what is it? You type in something and it tries to fill in the rest of your context for you, right? Yes, you can use RAG with type ahead search, but that is an implementation that you have to add in. RAG by itself is purely augmenting the capabilities of the LLM. Hopefully that clarifies. Sankalp, yes, the graph RAG, it depends. Like I said, there is a graph DB. It depends on how the graph is built. But the graph is generally, it's a collection of entities and relationships. Okay, and I think I answered that already, Sankalp. I'll be talking about how to construct it. Okay, is knowledge graph still in form of vectors? How is it different from the vector DB? So the vector DB here, that's a great question. And thank you for drilling down, Moni. I want to stress and I want to emphasize with vector DB, we have unstructured text that is stored in, of course, embedded form in its vector representation form. Okay. And hence, when we pull from a vector database, when we pull relevant documents that are relevant to the query as retrieved context, right? This has a lot of unstructured text that is being pulled as relevant, and that is open to interpretation. Okay, it depends on how similar the document is to the query. Okay, and that's always subject to interpretation. That is a con of working with vector DBs, and hence it's the graph DB that's working with structured data. What is structured data? When we think about structured data, it's facts together with their relationships. That is graph DB. Okay, so hopefully that point is coming across. Can you also speak for building vector DBs and knowledge graphs? Yes. What is GraphRag? Now, GraphRag is the name of the pipeline that we give. It's this whole process where instead of doing naive RAG, we are augmenting the capabilities of the LLM with a graph DB. So I can't draw this visual here. Unfortunately, my whiteboard decided to give me some issues. Imagine you have a graph DB here. Okay, the graph DB is providing, in addition to the vector DB providing retrieved context, the graph DB is also providing context, which is used by the LLM generator to produce a response to your given query. Okay, all right. So I'll keep moving forward. I still see there's a lot of questions. I want to quickly get into constructing of the graph itself. Okay, so now is a good time. I'm going to quickly walk through how do we construct a knowledge graph. Okay, and there are some important concepts that I'll come back to, but I wanted to show you, since this question is coming up to a lot of folks, let me show you what a graph DB looks like. I'm using Neo4j. Neo4j is a graph database. Okay, and in this graph database, I have constructed a graph. Okay, how have I constructed it? This is my GitHub repo, and I forked it from the original authors with my own specific changes. Okay, so you'll have this repository to view in your own time. I'm just going to look at the specific piece where I actually constructed the graph. Okay, so in here you will see the graph construction. I'm walking through the graph construction here for you. I have this question. I have this sentence that says Albert Einstein has studied physics. He's won a Nobel Prize in physics, and he's basically from Germany, and he's won a Nobel Prize in physics in the USA. Okay, so if I have to build a graph based on this information, this factual information, this whole sentence, okay, multiple sentences actually, how would I do that? I'm using Neo4j as my graph database. Now, there are a lot of other graph databases. I personally worked with AWS Neptune, but for the purpose of this little talk here, I'm showing you how to construct a graph in Neo4j. Okay, and here we are saying we are creating, what is a graph? A graph is a structure that has nodes and it has relationships. The nodes are entities. Here, you have a person entity, which is Albert Einstein. The subject is another entity. What is the subject? Physics. The Nobel Prize, he won a Nobel Prize, that's another entity. What are the countries? Germany and USA. What are the relationships? Studied, won, born in, died. Okay, and you'll see that I'm talking to the graph database here, the Neo4j, establishing a connection. And what you're seeing here is the cloud instance of Neo4j. It's called Aura. Instead of running it locally, I've decided to use Neo4j's cloud instance. I signed up for a free trial, and hence you'll see this little nagging thing saying I have 7 days left. But for now, this is enough to get the point across, right? So let's walk through this. So I'm constructing the node. I have person node, I have subject node, Nobel Prize node, country node. Okay, I'm creating the relationships here. Okay, how do I create those relationships? Now, when we interact with Neo4j, we use a query language, a graph query language. The graph query language that Neo4j specifically needs is called Cypher. Okay, so this is Cypher syntax to create these relationships between the node entities. Okay, and you'll see that these relationships are being created between person, who's Albert Einstein, and the subject physics. And what is the relationship? Albert Einstein studied physics. Then you have the one relationship. Albert Einstein won the Nobel Prize in physics. The born relationship. Albert Einstein was born in Germany. Albert Einstein died in USA, right? He also won the Nobel Peace Prize in USA, but you could also have the died in relationship. And how are you constructing the graph? You can see that here's the building of the knowledge graph. It's establishing the connection with the Neo4j database. It's creating the entities and the relationships. Okay, so this takes care of it. All right, and then how would you query? How would it look once you constructed it? This is something that I had already run. So this is the Neo4j. This is my Cypher queries, and I have the query explorer that I'm using in here. Okay, so I had some queries that I had run already. Here, what I'm trying to do is I'm saying, give me all the nodes and their relationships. Okay, all the nodes, relationship, a node connecting to another node and its relationship, return them all. And you'll see when I execute this, you'll see the graph that has been constructed. Okay, I'm zooming in, but yes, I hope you're getting the essence here, that this is your person node. Subject node is physics, studied with that relationship. He died in USA. He won the Nobel Peace Prize. He was born, no, Albert Einstein was born in Germany. Okay, this is the knowledge graph that has been constructed in Neo4j. How are you querying it? Using cipher queries. Okay, now when I worked specifically with another graph database, AWS Neptune. Now it's very similar to the Neo4j graph database. You can do the same thing. However, the query language that it uses, it's called Gremlin. Okay, so remember, I've given you two different graph databases, and I'm showing you how to construct the graph using this walkthrough and with the Neo4j console. So hopefully those questions that were there in terms of how do you construct the knowledge graph, how do you build the knowledge graph, how do you query it, here we go. Okay. All right. So going back to the slides again to continue with this, I think you've all gotten what is the you constructed a knowledge graph. You're now constructing a graph DB, right? You constructed a graph DB with the nodes and with the relationships, and you're going to use this in a graph RAG pipeline. Okay, I'm helping tie everything together. I'm giving you the concepts, tying everything together. In your graph RAG pipeline, you have a user query. You're doing retrieval from a knowledge graph that has been constructed, as you saw. Okay. Then you're using that to do augmentation, right? You're augmenting whatever is the context that's being retrieved here. You're augmenting the user query. Okay. And you use that augmented query to feed into the LLM generator. And that gives you the response that you need for your query. Okay, so what are the key takeaways so far? We've seen we've talked about what are the pure using an LLM in a chatbot. What are its limitations? We've spoken a little bit about NaveRag. Okay, what is NaveRag? Why did we move from using a straightforward LLM, a chatbot, to talking to an LLM with a RAG implementation? Then we also said we can have not just a vector DB, vector database, which is working with unstructured text that has its cons. Okay. Instead, I can also provide a graph database, a Neo4j graph database, an AWS Neptune database to retrieve structured data from and provide that as relevant context to the LLM generator to give me a more holistic response, more structured response with reduced ambiguity. Okay, so these are the key takeaways that we've covered so far. All right, so I'm going to continue on with a few more concepts, and then as each piece comes in, I'll step into the code to show you the how. Right, so I'm doing this as breadth first, then the depth. Okay. All right, so let's keep going. Now, when you're looking at how do you construct a graph, how do you scale this graph in production? There are a couple of optimizations and best practices that you need to keep in mind. What are they? Right? So I'm not saying that your retrieval needs to be from a vector DB only or from a graph DB only. Instead, use a graph DB to complement your vector DB, right? What happens with that? You're getting a much more holistic response with reduced ambiguity, right? So this is your vector search, right? This is where this circle is where your pure RAG sits. Of course, there was another point on BM25 algorithms, which uses keyword search. Now, keyword search, you would see that as another circle. And I wouldn't go into that in depth today for today's topic. The reason being today I'm focusing more on a graph-based RAG. Okay, but that was a great point. So keep in mind that you have vector search. You can also do with RAG, you can also do hybrid retrieval using BM25 and vector search. But however, the same problem that exists with naive RAG comes in there. The response that is generated is still unstructured data, right? It hasn't captured the connections that are there in your database, in your knowledge base. Okay, and hence you would want to do a graph search, which is this circle. Okay, now we don't want to do vector search only or graph search only. We instead want to complement the graph search together with the vector search. That improves the response that you get out of the LLM generator. Okay, and that becomes your graph RAG together with name RAG. Okay, and that's your hybrid retrieval system. The hybrid retrieval is vector search together with graph search. Put this together into your graph RAG pipeline. Okay? All right. So now, when you've constructed the graph, great. You saw how the graph was constructed here. In this case, I just had about how many nodes? 5 nodes here, right? And I had about 4 relationships. Small scale graph, very good. But in the real world scenario, and I'll give you an example. In my example, the one that where I've used graph searches for has been for identity resolutions. During my time at GoodRx, I was a technical lead for the incentives platform. And the core problem that we had was incentives is essentially discounts or offers. And the core problem that we had was we had a large number of account identifiers for every touch point. For users would have different touch points and hence different IDs in the browse behavior. They would browse on the price and coupon pages, right? As anonymous users, then they would sign in, they would get another identifier, okay? And finally, at the point of sale, which was at the time that a GoodRx user goes to the pharmacy and presents their prescription for discounts that they could be eligible for, we couldn't recognize the GoodRx patient who was providing their first name, last name, and date of birth, mainly because we couldn't map that to the GoodRx identifiers to which the discounts were associated with. And for us, our team, we had to improve that because that meant dollars being lost because we couldn't drive customer engagement, right? And we use graphs to resolve this, to resolve the various account identifiers into a single unique entity, right? Dipti could be, account ID 1, account ID 2, account ID 3. But at the end of the day, she's still Dipti when she's going to fill her prescription at the pharmacy point of sale. Okay. Now, for us, we were doing this at the point of sale, right? And we can't keep the patient hanging for long at the pharmacy counter. We are all people who want to get things done and move out fast, right? So what happens? We can't traverse multiple levels in the graph. I can't be traversing multiple levels because why? Latency is a concern. Okay, so the graph retrieval depth matters in this case. In a production system, the number of traversals that we want to do, we want to limit it. Second, we also want to avoid noise. We don't want to pull in all identifiers that may or may not be related to Dipti. It's just noise, right? And you're going to slow down that query. What does that mean? Latency, increased latency. The minute the latency we have a latency trade-off, we are going to default saying we couldn't find Dipti in the system, so hence we couldn't give discounts. What does that mean for the business? $1 lost on the table. Okay, so keep that in mind, right? Graph retrieval depth in production really matters, especially when you're designing latency sensitive systems. Okay, now your query performance. Like I mentioned, this particular graph was very small, okay? And hence the scale is not known. But in this scenario, when you're searching through a graph which has, let's say, 200 or 500 entities with 32 relationships, we'll see that demo as well, right? Searching through that graph database, when we think about databases, what comes to your mind? We want to index it. We want to improve the query performance. Okay, how do we do that with graph databases? We do a full text index on the entity names. We also create vector indexes on node embeddings, and we create constraints on unique properties. Again, concepts, I'll show you the how in the demo. All right. Now, the schema design, I think one of you was also already mentioning, it depends on how we design the graph, right? So a graph has a schema. What is a schema? It's a blueprint for how you're going to model the entities and the relationships. You don't want to have too many nodes. You don't want to have too many relationships. What is important here? You don't want to slow down the queries. You want to keep your knowledge graph focused only keep it focused to information that adds value to the retrieval. Okay, why would you do that? Right, because in your graph database, you're only retrieving structured data as relevant context to augment the query. You don't want to retrieve everything that's not focused information. Okay. Second, you don't want to build the graph in real time. Every time, in this example that I spoke about, Dipti, the pharmacy point of sale, filling her prescription claim and using a GoodRx coupon to see if she has discounts that she can apply, right? If the graph, the GoodRx's identity graph, or it was called identity graph mainly because it was composed of identifiers, account identities, right? But in reality, it was nothing but a knowledge graph. If we are building that knowledge graph in real time, imagine we are losing time not just on building the graph, but also on traversals, the query traversals, right? We don't want that. So we want to definitely build the graph um, offline asynchronously. Okay. And that was done for us by our data scientists who looked at historical prescription claims to build that identity graph for us. Okay. So hopefully this example is resonating and it's tying all of these principles, the production principles, together for you with a concrete example. Okay. And of course, caching, right? Because there might be some parts of the graph, subgraphs, right, which are being traversed more frequently. Obviously, we all know, for at least those of us with engineering, software engineering background, we know caching helps improve performance. This is no different in here, right? So scaling and cost considerations, four things to keep in mind. All right. Now we look at the knowledge graphs. You're going to start deep diving into a little bit of the knowledge graphs itself. I've showed you one example of with the Albert Einstein scenario. Okay, to introduce you to some of these concepts, I spoke about nodes. What are nodes? They are nothing but entities. They can be people, it can be places, it can be concepts. Okay, and they are represented as nodes in the graph. Edges are nothing but relationships, relationships between entities that describe how the entities are connected. So, for example, let's consider another completely different example. Alice acted in the movie Frozen. Well, I don't know if we had Alice, I forget now. I'm just making it up. Bear with me there on that front. Alice acted in the movie Frozen. So this can be modeled as Alice acted in movie, or you have the inverse relationships, right? The movie Frozen had an actor named Alice. Okay, so this is your structured navigation. And in fact, here you'll see that this particular query, I'm saying match all nodes which have the subject physics, okay? And the relationship should be in this direction, right? But in fact, you see the relationship exists from Albert Einstein studied physics. But here with this query, I'm looking in the opposite direction. Physics was studied by who? Right? But there is no this relationship hasn't been modeled, right? So it's the only structure, the navigation that exists, it's one direction. And so when I execute this query, this cipher query, you'll see it will return no records. However, if I change it, if I change the direction here to say, okay, all right, I do know that this relationship hasn't been modeled, I'll query, it'll say this is physics was studied by Albert Einstein, and this is pulling up the record. Okay, so that's what it means by structured navigation. All right. So this pretty much mirrors this graph, this knowledge graph with nodes, its relationships with the structured navigation. It mirrors how you would how would you how is your real world knowledge going to be represented within a knowledge graph? Okay. Now, you can also have properties on these nodes. The properties can be this person, Albert Einstein, had a birth date he was born in 1942. I don't know if that is true, by the way. I just gave the person name as Albert Einstein, and the nationality is German. Okay. And if you think about these relationships, you'll see that it is actually a triple. It has a subject. Okay. Paris is the subject. France is the object. What is the predicate? It's capital of, right? So the relationship is the facts and the nodes, the entities, or the facts. These are the subject. The relationships are predicates. Okay, subject and object becomes the nodes. Okay, and many knowledge graphs adhere to what's called as, they have standards, right? They use the resource description framework, which formalizes these triplet structures. And going into a little bit about what is the standard that is used to create that knowledge graph schema, using the resource description framework says that you can have an ontology, a taxonomy, and this helps in inference with the knowledge graph. So what is ontology? Where you're defining the entities, the type of entity, the type of relationship, what kind of rules are there in terms of how they connect. So let's consider this example, right? Um, let's say John treats Emily, right? John is a doctor and Emily is a patient. That is your ontology. Okay, they are your entity classes. John and Emily, they are your entity classes, and treats becomes the relationship. A taxonomy is nothing but it's a hierarchical organization, right? So it's pretty much saying if John treats Emily and John is a cardiologist, then it's very easy to infer that John is a doctor. Okay, so remember the graph rag, because of the ontology and the taxonomy that's implicitly defined within the knowledge graph schema, inference such as these becomes easy to do. Okay, but I do want to mention that most of the knowledge graphs that we have moved toward, this was true, having the first coming up with a schema and then defining the knowledge graph. This used to be true before a few years ago. Now, for graph databases like Neo4j, for AWS Neptune, you start populating the graph with the nodes that you wanted to, and then you go in and start formalizing a schema, right? It's pretty, you don't need the schema to start building the graph. Okay, you can formalize the schema once you have some data in the graph. Okay, so keep that in mind. Earlier with Facebook too uses knowledge graphs, by the way, right? How does it use the social media, Facebook, Meta, however we would like to call it? It's a social media platform, and you have friends connected to their other friends, right? And you have third party, you have transitive friend relationships. They're all constructed with knowledge graphs. Okay, and that was prevalent, and it was a very prevalent use case before knowledge graphs could also be used to improve search. Okay, so keep that in mind. Knowledge graphs are nothing new. It's just that knowledge graphs are being used today to improve search mainly because the basic RAG implementations are just not enough. Okay, so that's another key takeaway from this slide. Okay. All right. So when you construct a knowledge graph, I went through that little example where I worked with that identity graph, right? It was curated. The graph was manually populated. How was it populated? We had data scientists, we had data engineers who were looking at prescription claims. They were pulling in data from Redshift. That was the database that was hosting the historical prescription claims. The knowledge graph, the identity graph was constructed from that, right? So it integrated the prescription claim records to pull in all those account identifiers. So the identity graph could say Dipti with an ID 1 or Dipti with an identity 2 is the same as Dipti with the first name of Dipti, last name of Ashwath, and date of birth as XYZ. Okay, so it had to be defined. Domain experts do build the domain graph using the data sets that they have available. Then we have automated extraction, right? We do have to infer when you have a query. The query that I love is who was the son of the man named who was the son of the man who defeated the usurper Electus, right? You have to extract the entities, right? And then query the knowledge graph for those entities, right? So there are numerous ways to doing so. Today, in the demo, LangChain's LLM Lang Transformer is pretty much what we are using to extract those entities and relationships from the query. Okay, so I wanted to mention that. Okay, all right. So let's keep going. So I think I've already outlined the pros and the cons of the knowledge graphs. This is another important aspect to consider. Some of the challenges here, right? I've already mentioned it. The scale of the knowledge graph is always a primary concern. You want the knowledge graph to be easily scalable and traversable because of latency constraints, right? When used within a graph RAG pipeline. The other aspect of it is you have privacy concerns with sensitive connections, right? Especially if you're working with account identifiers. Um, we had a lot of heavy lifting to do when we said we can't construct a Neo4j identity graph in our staging environments, mainly because we couldn't share the account identifiers. This is sensitive data, especially in especially when you're working with prescription claims, right? So it was sensitive. We had we had to work around it, but I'm not going to go into the specifics. But you're getting the some of the challenges that comes with constructing and working with knowledge graphs in a production system. Okay. All right. So applications of knowledge graphs. I spoke about one application that I worked with. More recently, in my fractional CTO role, I also constructed a graph neural network model I trained the graph neural network model and stored it in AWS Neptune. Okay. Why did I do that? This was for, I had to merge enterprise data, essentially customer records across the HRM sources, right? Multiple HRM sources. I had to identify that, match the identities and merge them to create a unique digital identity. So that was another application that I worked on that leveraged knowledge graphs. Of course, I had to train a graph neural network model before I could build that graph myself, right? So keep in mind, you can construct a knowledge graph manually, or you can train a graph neural network model. Okay, I've done both, and I just wanted to mention those as applications of knowledge graphs. And then you also have the search, right? You're augmenting a Claude, right? A Claude is augmented with knowledge graphs, right? Google search engine, who knows? We don't, at least I don't leverage Google search anymore unless it's the AI mode, right? And all of those have knowledge graphs for retrieval in some mode of fashion. Recommendation systems, healthcare systems, enterprise data, especially if you're working with a customer support chatbot where search is involved, right? You have to pull up the customer's previous purchases, the customer's complaints, their support tickets to respond to whatever query that they have in real time, right? So a knowledge graph would be helpful in connecting those data segments together. Okay, so hopefully this is giving you an idea as to where we would use it. Neo4j. Now, like I mentioned, Neo4j is a property graph model. It doesn't require a global schema upfront. Okay, you can start adding the data and start enforcing the constraints based on need. Okay, all right. So let's keep going. I think I showed you this already. Now, what I did want to mention was the other walkthrough. The other walkthrough that I quickly had before I pass it on to Rohan was, here's another application that I have. I'm constructing a knowledge graph, right? I'm using healthcare data. Okay, and these are very simple applications, by the way. These two are very simple applications to show you what it takes to construct a knowledge graph and to build that hybrid retriever. What is hybrid retrieval? Where you're using a graph DB and a vector DB to pull relevant context that you will then use as context to the generator. Okay, so this is that example. Okay, this is, I've constructed the knowledge graph for the healthcare data in here through this kgprep.py, and I've left you a lot of footnotes so you can so you know what it does, right? So this is creating a knowledge graph with providers, patients, and treatment relationships. This is how the CSV looks like, right? There's a provider, they've treated a patient, they have specialization, and they have a bio. The doctor, the provider has a bio. Okay, all that I did here for my app that I wanted to where I wanted to demonstrate hybrid retrieval, I constructed the knowledge graph. Okay, I constructed the knowledge graph with just the provider node, the who they treat, and with their bio. Bio was the description of the provider, right? And that's pretty much what I did in this knowledge graph prep. You can walk through this. You'll see that how have I gone about doing it? Please walk through it. Okay. And the next piece is the hybrid retrieval, right? So how do you do hybrid retrieval? First, so we've already spoken about how to construct the knowledge graph. We construct first that vector index. Remember, you have to construct a vector index to speed up those queries on the graph, right? So this is a vector index that's being created on the node healthcare provider on the comprehensive embeddings, on the vector embeddings that are going to get created here. Okay, so we are creating a vector index named health providers embeddings. Okay, so that's what it gets named in here. We are using the bio. We are talking to the OpenAI embedding model to generate the comprehensive embeddings attached to the provider node. Okay, this is nothing but it's it's the embeddings which is now going to be indexed. Okay, all right, and then there are a couple of verification steps. What does this help with, right? How is this hybrid retrieval with that vector index helping? Okay, so for example, I have a query in here where I say, give me a list of healthcare providers in the area of dermatology. Okay, now, if I were to do simple vector search, it would only pull up the healthcare providers, right, whose specialization is in dermatology. But you will see that in the CSV file, there are providers whose specialty is maybe they are pediatricians, but they are providers. In their bio, they say they work as skin specialists, they work for acne treatment, they are eczema experts, they work with cosmetic dermatology. Okay, so with this with the vector with this hybrid retrieval using the vector embeddings to and the provider nodes together with the vector embeddings, the knowledge graph that we've constructed, we are able to match the healthcare providers in the area of dermatology using their bios as well. Okay. Some of you would argue that yes, we can do this with vector search, but just give it a try. Just remove with the same application that's there, use the same CSV, just create a pure vanilla rag and see what the same query would bring up without having a knowledge graph and without having a hybrid retrieval. That's my homework to you folks, right? You're seeing the nice pieces of it, but for you to be convinced that the knowledge graph with its hybrid retrieval is going to improve the response you get for this query, just do that homework for me, right? And it's going to you're going to walk away with the benefits of using GraphRag. All of what I'm mentioning in this webinar, it's going to sink in 100%. Okay. All right. So in the interest of time, I'm going to leave you this as something that you can walk through. I have, like I mentioned, explicit footnotes are in here and comments. So you can take this and look at it in terms of how we are doing it. All right. So the last bit of it is the graph rack pipeline. So what have we covered until now? I'm going to hand it off to Rohan very quickly, but I want to talk about what have we covered until now with that little visual. So we've seen how to construct a knowledge graph, and I've shown you how to do hybrid retrieval using both a vector database and a knowledge graph. How can we construct a knowledge graph and how can we do hybrid retrieval? That's what we've seen. We haven't yet seen the graph RAG pipeline. What is a graph RAG pipeline? The graph RAG pipeline is nothing but it's this whole sequence put together, right? Let's go back here. It's this particular flow that's working together. You have a user question. Okay, we are going to extract entities from that user question. Okay, we are going to query the knowledge graph to get relationships that involve those entities. Then we are going to do vector search. Okay, so we are going to query not just the knowledge graph, we are also going to query the vector DB. Okay, we are going to combine the relevant context from both of these into the graph, into the augmenter, and then the generator is going to process the response to improve the factual accuracy of the response that's getting generated. That is a graph RAG pipeline coming together. And I have the last demo, which I will reserve for the end after Rohan finishes by walking through this graph RAG pipeline. Okay, and what are the various components that go into it? All right, I know we've had a lot of questions in the chat and I haven't been looking at it, but I'll pass it off to Rohan now. And if time permits, we can come back to the questions at the end of this webinar. Rohan, over to you.
Thank you so much, Dipti. Really appreciate it. There's lots of questions are coming in. I think there are two pieces. One is it possible for us to share the GitHub link with the team, with the folks here?
Yes, Rohan, I've attached it
If
in the
you can, that'd be
slides.
super helpful. Anyways, folks, I think I've been pasting one message. If you haven't yet, do join in our community. This is not like a sales pitch or anything like nudging you folks. We do keep sharing. We're just trying to build something over here wherein we'll keep sharing resources with folks over time period. We did some AI launchpad, not sure if a lot of you were part of it. And now we are doing these master classes almost every week. So if you could, I'm sharing the link over here. Feel free to join it. Over there, we'll keep sharing these decks and these repositories so that you don't miss out on it. One more question that keeps coming up is the recordings. So what happens is we do these sessions once or twice live before we are like, okay, this topic has had enough mileage. Then we move to creating recordings out of it. So maybe there is hence there is some lag in the session to the recording stage. So yeah, so just hope it's understandable. Once those are available, we'll be happy to send it to your emails or even most for and if and when they come, they will be first shared on Discord community, by the way. Recording, Arun, it will not be shared immediately. Like I said, we do run these sessions at least 2, 3 times live before we convert them into recordings. I hope it's understandable. I'm sharing my screen once. Very quickly, folks, I won't take much of your time. Let me run a very quick poll over here, and I'll tell you why I'm running this. This, I think, initially we realized a lot of people are in the early stages of their AI journey. There's one poll that we have is we want to understand which of the following resonates with you the most, and I'll just like come to it why. Very quickly, give me like next 5 minutes. I'll talk about very quickly what I do with Kickstart before we move to the demo. I don't want to be an interruption for you folks in any way, but it's I have to do this. So interview Kickstart, we have two offerings. One is interview prep up leveling, and the other one is AI up leveling. Uh, in terms of what we are seeing in the market, a lot of money investment getting into AI. No, nothing new. But where it is going, majority of it right now is going in the infrastructure. Then next, it's more on model development, and then industry specific solutions are being created. I think FAANG has already invested $53 billion so far in the Q1 of 2025, and more of his money is getting committed and being poured into. Why this is relevant, I think it's very clear wherever the money is flowing is where the jobs are also flowing in the market. And the compensation on the job is also flowing in the market. So we are seeing like a massive growth in AI ML roles, almost 1.65 times in 2025. Not just AI ML roles are growing, roles associated with that domain are also increasing. For example, data engineering, data sciences, they are also increasing. In terms of the job growth, it's the different type of ML type roles that are coming up. Gen AI engineers, machine learning engineers, even a new breed of roles is coming, which is modern ML engineers. I'll come to that later. And there's another very common piece that is trending, which is AI preference in even in traditional tech roles. Let's say if you're engineering manager, AIEM, AITPM, software engineers 3.0. So even there's an emergence of AI preference in traditional tech roles. So what is this leading up to? It is predominantly leading up to two pieces. One, most of the jobs are predominantly coming with AI-enabled JDs. On top of it, the I would say the remuneration surplus. There is what we call it's an AI ML surplus compensation over here, which is also getting to the folks who are moving into this particular domain or getting themselves up leveled or AI enabled. However, there is one thing like I think very common is this thing is not as of now it's not impacting each and every role equally. The impact is distinct and different across different roles. For example, 1 in 4 software engineering roles now seek Gen AI expertise. However, that prevalence is a little bit lower on the engineering manager side, like 25% there, 20% here. And on top of it, 10% of the JDs as of today are now mentioning agentic AI requirement in them. So a different roles are getting impacted very differently. And that is creating a lot of confusion in the market. Not just that what is required in the roles, on top of it, the Moore's law, like everything is changing so frequently. One day, I think again, I just like very cool. Like the one time it was like vibe coding was the buzz. Now there was like something around Kiro or something from Amazon, if I'm not wrong, which was like it is the vibe coding killer. Again, so many things keep changing. Uh, there are four what we call internally is 4 stages of AI denial. So if I call it out, again, this is coming very clearly in the poll also. 33%, 45% of you respectively are saying AI is moving too fast for you, or there's just too much out there. That's almost 80% folks who believe this, who believe in this. And that is what we are seeing as well. And to help you declutter is what we have come up with is an AIQ framework, which helps you understand how to up level. In terms of up leveling, there are two parts. One is augmentation, which most of you folks said you are either working with LLMs or you're building your own, improving your productivity with AI copilots. What Interview Kickstart does is helps you move from augmentation to transformation. In terms of transformation, we believe there are three core paths. One is you build complex AI agents. Second is you build on top of complex advanced models. And third is eventually build complex models. Depending on your skill set, how in depth are you into coding, your mathematical skills, your statistical understanding, you can move from, let's say, building a complex AI agent today to building complex ML models. And we can help you move from each step further depending on wherever you are in your transformation journey. On top of it, it is not just about how interview Kickstart can help you. It is also about just to see where you are today and what sort of roles you can target in the market. For example, if you want to build complex AI agents or Gen AI apps, the roles are predominantly AI enabled roles, AI software engineers, AI product managers, AI EMs. However, if you want to get into a position where you're building on top of advanced ML models, model ML engineers are the core roles that are being in the market right now. And then there is building of model complex ML models, wherein you become deep advanced ML engineers, AI researchers. Like I said, the more you progress or the more farther you want to go, the coding requirement, the mathematical requirement, those sorts of things will keep on increasing. And where we position ourselves, if somebody who is in the early stages doesn't want to get in depth into coding and machine learning, we have built for them edge up courses wherein they can get AI enabled in their existing courses, existing domains. If somebody is looking for advanced ML models, we have our flagship machine learning program. This is one of the most selling along with edge up. Advanced ML, since it requires a lot of coding skills, a lot of mathematical understanding, we do help you build that, but we do require a very strong foundation in that. Otherwise, it's not something that we would recommend. But that's something wherein somebody who's really looking to get into machine learning side. Again, these are the things your program advisors, we have mapped some people to you, can help you understand better. Coming to a very quick piece, all these courses come with a project centric approach because as of today, while the companies are asking for AI enabled skill sets, they also want to see some sort of a portfolio. And not just portfolio, even if you're doing some things in your job, that's great. But again, most of the companies, some people have very disproportionate access to different sort of projects. Hence, we help you build your projects with regards to your domain. It's super customized, and you work with an instructor one on one, and you have like capstone projects, self-guided projects, and by the end of your course, you have your own portfolio, which will not just like help you practically apply your skills, but also help you showcase to recruiters, what sort of your applied skills are. Just very quickly, sorry, once again, Edge Up is predominantly for somebody who wants to stay in their domain but want to be AI enabled. The duration for this course is a 3 plus 3 month split. The first 3 months we help you with the Gen AI skills, and the next 3 months are predominantly focused on interview preparation. The flagship machine learning course is a 7 plus month course, 7 plus 2 ideally. First 7 months are about learning company oriented AI ML skills. You build your portfolio of products, and then you transition to a new role if you want to. And then the advanced ML, which is like specialization of full across like full spectrum of AI ML. And again, you build your portfolio, all those things remain. Like I said, this is the full spectrum. It requires more commitment, more in-depth understanding. And it also comes with helping you transitioning to a new role if you want. Again, like we see a lot of people coming to us who are really like in the very early phases. We do recommend, if you're unsure, edge up is something that you should think about. If you are aware, if you are already building agents, then flagship machine learning is something that would be most apt for you. Coming to the pricing of these, again, these are list prices. There are certain scholarships on top of it. We do give you some sort of trial period as well. Coming to Edge Up is a 6 month course, like I mentioned. It starts priced around somewhere $8,900. Flagship is somewhere around 9,500, 10,500 USDs, and advanced ML is somewhere around 13,000 USDs. Again, there are certain scholarships for folks who like join in early in the cohorts. There's money back guarantee because we believe in their outcomes. There are alumni scholarships. If there are some alums who have taken some interview prep course or you want to reskill themselves, the alumni scholarships as well. Then we do provide placement assistance and we have financing options available as well. In addition, let's say somebody is not looking to get into AI sort of courses, we do have interview prep courses as well, wherein we help you upskill and help you prepare for FAANG Plus interviews, where there are mock interviews for you with FAANG instructors, like 10, 12 mock interviews you go through. Then there are 2, 3 month courses, which will help you crack those FAANG roles or the coveted FAANG roles, which help you bring that brand on your resumes along with the skills that you acquire. Again, that's all from me. We'll be back to Dipti. The core part being we help you have an amazing career. We bring to you AI that's customized for you. We are a top company, project focused company at the end of the day. And the core secret sauce, like I mentioned, is FAANG plus instructors and mentors in terms of outcomes. The average salary is somewhere around 250 to 300K. The typical maximum salary increment that people see, let's say I'm investing, let's say 10,000 in a course. What is the ROI? On the ROI is like the typical minimum is some 75,000 to 150K is something in terms of increment that we see for the people who go through our courses. So if you are even slightly curious, I'll say drop in a yes, speak to your program advisors, understand about our offerings. If they fit you, great. If they don't, we won't be pushing it on you for sure. Dipti, over to you. I think this was my part. I didn't want to I think we're already a little bit on the time, hence I wanted to rush through it a bit quickly so that folks could get more of the content and less of me. Over to you.
Thank you so much, Rohan. Folks, I'm just going to go back to sharing my screen. And thank you, by the way, for the extra time. I want to make sure that we get to the demo pieces. There were a lot of questions on the GitHub repo. It's on the slides, and I'm sure I'm linking you to it as well. All right. So a lot of prerequisites in terms of how to get set up. How do you get connected to Neo4j? I've left you a lot of instructions in getting set up there as well. So if you look at the README, you'll have these instructions in how to get set up. What is the project structure? Like I mentioned, I've forked it from the original creators, but I've added a ton of explanation because I knew time would be short for the webinar itself. So I added a lot of explanation, and I structured it in terms of at least the final demo. I've structured it in terms of how a production-ready application, a graph RAG application would look. Okay, so this is the production, the graph RAG pipeline, all of the pieces put together. Okay, before we come to this, I'll go back to the slides and I'll give you the last context, the last bit of context that you need to know before this demo makes sense to you. So this is a demo where we are going to look at where we're going to construct a knowledge graph using a Wikipedia article on the Roman Empire. Okay, we don't use all of the Wikipedia articles. I just limited to 3 because building the knowledge graph for 10 or so takes incredibly long. Okay, so what is the main point of this? I want to show you a graph RAG pipeline wherein we have the indices constructed, a full text index, a vector index constructed, which it'll retrieve relevant context from both the vector DB as well as the Neo4j graph DB that's being constructed. For any given query, we extract the entities. We use an LLM to extract the entities and then retrieve relationships around those entities that is retrieved from that graph DB. Okay. In addition to the relevant documents from the vector DB, that's used to augment the query that you would ask, and then you'd get your final response. So 4 pieces in the pipeline. Okay. Hopefully this is giving you setting up enough of the context. I also have data ingestion, and I know I remember seeing a question from one of you folks in terms of chunking and how do you pull the data, right? So there is a data ingestion piece as well. I'll show you that in the code in the interest of time. Okay. These are the contextual pieces that are explained explicitly in the slides. Okay, I'll walk through it in the demo, but I wanted to make sure that you knew that if you had access to if you get access to the slides here, you would be able to follow along and map it to what's in here. Okay, so let me quickly walk through this the code base here. So this is a graph RAG retrieval pipeline, which has the data ingestion piece. So you will see that I'm setting up a Neo4j RAG system. This is just the initialization pieces. What is happening in the initialization? Let's walk through it very quickly. Okay, so I'm setting up the Neo4j connectivity, right? I'm still continuing to use Neo4j as my graph DB. So all of those connections, okay, it's reading it from the env file, and then I'm loading the env through the library, the dot env load dot env. Okay, then I set up. I'm using the chat the I'm using a closed LLM model. What does a closed LLM model mean? A closed LLM model where I haven't fine-tuned it. I know there were a lot of questions in the chat in terms of RAG versus prompt engineering, fine-tuning, right? And I'll briefly touch on this because getting into the depths of it is will definitely take us a lot longer. But here, in the context of a closed model, I'm interacting with a GPT-4o mini model using an API, using its APIs. And hence, I need the API key, which is what I'm doing here. Okay, so there is no fine tuning involved. I'm just taking the closed model, GPT-4o, that has been the OpenAI folks have already trained. They have done reinforcement learning. I know there was another question there. I was looking at it while Rohan was speaking, right? I can also talk to reinforcement learning. Okay, it has all been the reinforcement learning has been applied. It's been fine tuned. Okay, and I'm just taking that model and interacting with it via the API. Okay, so just keep that in mind here. Okay, now I'm initializing the Neo4j graph. I'm setting up the generation model. My generation model is my 4o mini. Okay, remember the fourth component in our graph RAG pipeline is that generator, is that LLM generator, which takes the augmented context and generates that response. Okay, so this is the LLM model. I'm using the OpenAI embedding model. Okay, again, another closed model, two different models here to generate that vector representation. Remember, we spoke about working with text and then needing to convert it into a numerical representation, a vector representation. I'm using the OpenAI embedding model. Okay, all closed models, I'm interacting with it through APIs. Okay, all right, so this is my hybrid retrieval system. What is my hybrid retrieval system doing? It's combining vector and it's combining structured search. I'm setting up a vector index, okay? I'm setting up a full text index for entity matching on the graph DB, okay? And then I'm setting up an entity extraction chain for structured graph traversal. How do I do that? Here's my vector index. Here I'm using the land chains Neo4j integrations. I have left the links in my, if you look at the README in here, I have the links to the additional resources in terms of the APIs that I'm leveraging. Okay, so feel free to look up their API references. It's added in the README as a reference. Okay, all right. So I'm setting up the vector index. Okay, and what is it saying? That I'm going to create a vector index. I'm going to look for document nodes that have both text content and the embedding vectors. That's what this is doing. Okay. Then how do I extract the entities? By the way, I'm just setting these up. I'm just initializing them. Their actual usage we'll see in the later functions. Here, I'm extracting the entities. I'm using an LLM, the same GPT-4o mini that I used for my generation. I'm using that same model, right, to extract the entities. Because remember, once I extract the entities, from the question, the user query for this whatever the user wants to look up or wants to search, right? I need to then look into graph DB, right? So how do I extract the entities in the query? This is how I'm doing it. Okay, I'm setting it up and initializing it. Okay, just keep that in mind. Then I'm creating that full text index on the entity nodes. So while this is working, while this is setting up a vector index on the vector embeddings, this is creating a full text index on the nodes with the entity label using the entity ID property. Okay. All right. So so far you're with me. This is all part of the setup, and hence you'll see the setup retrieve. What we just spoke through was through setup retrievers. Then you have the setup chain. Okay. So what is your setup chain? How does it flow through? Right. So this is your query. This is your user query. Okay. Then from the query, you're going to retrieve information. So you're going to ask, when did someone become emperor? Who is he? I'll show you that in the demo. Okay. And the search is going to be the search is going to retrieve information from both the knowledge graph as well as the vector DB. And it's going to say Augustus became emperor in 27 BC. Okay. And the question is going to get passed through. So these are the four different pipelines in this retrieval flow, and they are being set up here. Okay. All right. So I'm going to quickly keep passing through. We have a chat history, by the way. This is the short-term memory that's being used. The same concepts. Remember, AI agents, when you use AI agents, they use the same, you're using retrievers as tools, you're providing retrievers as tools. They carry the same concepts. So it's not use it only for this particular session and throw it away. You're going to keep these concepts. It's going to move with you in your AI upskilling journey. Okay, so this is your short-term a memory, which is nothing but session history. Okay. And if there is session history, it's going to take that information, because if I were to if I were to query saying, when did he become emperor? Who does he refer to? I already have context in my particular session history conversation that says I was referring to Augustus. Okay. And this is pretty much how the chat history is being tracked. Okay. And then this is the answer generation pipeline. Okay. So what is your RAG chain? Here's your RAG chain, right? This is your search query. You passed it through the retriever, which did hybrid retrieval. Okay. Then your question came through. It passed through the answer prompt. The answer prompt in here was it combined the context together with the question into the final prompt. Okay. And then you sent it to the generator. You're sending it to the GPT-4o mini LLM, your generation model. You're extracting the response, formatting it using the string output parser, and dumping the response. So this is pretty much your whole setup of the complete RAG pipeline. Okay, it still hasn't been called, by the way. This is just the setup, and I wanted to show you how it's being set up. Okay, now let's look at the data ingestion pieces of it. You'll see that in my when I start with when I start this particular code program, what is happening? The initialization of the Neo4j RAG system with all of those setups were done. Now I'm going to ingest the data. What is data ingestion doing? Data ingestion is essentially looking at, where's my data ingestion? Let's see if I can go to it very quickly here. So it's reading the Wikipedia article, and it's constructing the graph. In the slides, I had mentioned that we are using we are using the Lang chains ecosystem for constructing the graph. Okay, so here's the Wikipedia loader. We are doing the chunking. Okay, and now is a good time for that question that I asked. Why do we chunk? If folks can drop in their thoughts on why we have to do chunking, that would be awesome. And I'll keep going at it. Not that I'm ignoring you. I just want to in the interest of time, just moving through it, but I want to make sure that you understand why we are chunking it. So we are chunking the Wikipedia article that we've loaded. Okay, then we are leveraging the LLM graph transformer. LLM graph transformer is coming from the LangChain. Okay, it's coming from the LangChain, and like I said, I've linked all of these APIs that you can look at in your own time. Okay, so let me go to where I was there. The graph transformer here is converting the Wikipedia article, the chunked documents, and it's going to create a graph, and it's going to store the documents and graph in a graph database like structure. Okay, it's doing this automatically for you. So please feel free to look at how the LLM graph transformer is working under the hood, where it's reading these chunked text documents, creating that knowledge graph, and then storing it into the graph DB. Okay, and then remember, we are also keeping the original text for vector search by virtue of these parameters added to the API call. Okay, so I'll leave that as a homework where you look at what is the API doing, how is it working under the hood, why is the include source enabled, why did the T enable the base entity label? Okay, all right. So now I I also have a clear database, right? Because right now in my Neo4j instance, I had the Albert Einstein knowledge graph that was loaded. Okay, so I'll be, when I run this pipeline, going back to my code snippet, yeah, when I run this code snippet, I clear out whatever is in there to reconstruct the graph for this particular Roman Empire Wikipedia article. Okay, so that's my function call there. All right, then let's look at the next pieces, which is the more important pieces. Okay, so for this, given a question, we are asking the Neo4j RAG system. Okay, we are asking for it to respond, right? You're doing a search. How did the Roman Empire fall? We are searching the graph RAG system for a response on to our query. Okay, how does this work? Right? How does this work? There are a couple of other functions that I did not cover. So you'll see in the retrieval, we are making a call to the structured retriever, right? Which is the graph DB. Okay, how does the graph DB work? This is the structured retriever where we've already extracted the entities. Okay, the entities have already been extracted. We are querying the Neo4j graph for the relationships. And I'm using cipher queries in here and take a look at how the structured retriever is functioning. Okay, we are extracting entities, we are finding matching nodes in the graph using fuzzy search. What is fuzzy search? If Augustus is misplaced and I forget to type in, U and S in between, it does a fuzzy search. It says, okay, perhaps she meant Augustus, but she mistyped it. Okay. Um, you can also, for those who are curious about look ahead search, right? You can build it in here, but you'd have to explicitly add that functionality. You won't get that straight off the bat. Okay, you'll have to add that logic for look ahead searches. So here in your structured retrieval, what you're doing is you're finding the matching nodes with fuzzy searches. You're retrieving the relationships. The relationships are your structured data that is added as context from this structured retriever. Remember, it's hybrid retrieval, right? We are using structured as well as unstructured. Then you have the unstructured data, which is nothing but the vector-based similarity search. Okay, this should sound very familiar. This is no different from the vanilla RAG systems that you might have seen. So I won't step into it. Then for the retrieved information from the hybrid retriever, you're combining the structured as well as your unstructured data and providing it as context. And you can see that this question, the question when asked, okay, you had that chain that was set up in here, right? You had that whole chain with the 4 steps. It's stepping through each of them, retrieving it, augmenting the query, right? And feeding it to the LLM generator, the GPT-4o mini, to generate the response. Okay, so now let's quickly look at it in action. I'm going to stop the share and I'm going to go to my visual studio where I can show you this very, very quickly. Okay, and just give me a minute. Uh, there we go. All right. So I had the same uh, uh, um, code that we stepped through. I'm running this. This is a graph rack pipeline, which has those 4 different components all working together. Okay, so let's see. So it's initializing the Neo4j RAG system. All of it is being set up. It's loading the Wikipedia articles. And remember, I've said I just need 3 of those Wikipedia articles loaded. Because in the interest of time, I'm building the knowledge graph on the fly here. Okay. So while it's not an efficient production system, I wanted to put everything together to show you this. But keep in mind, when you actually move this into production, the knowledge graph building should happen in an offline or in an asynchronous mode. Okay, so this I get this with the beautiful soup parser when it with the Wikipedia loader that I'm leveraging. It's coming. It's happening from that Wikipedia loader. It's a LangChain functionality, right? But never mind. It's just a warning. It's not an issue. So give it a couple more seconds. It's constructing the graph. It's constructing the graph in here. Not happening fast enough. Not happening fast enough. Few more seconds, folks. Right. Meanwhile, maybe I can take some questions that are outlined here while this is working through. Okay, there we go. It's storing the documents. So the graph construction that you saw, loading the Wikipedia article, parsing the graph, extracting the entities, extracting the relationships. That took a while. Okay. And then the system is ready. I had some simple questions going in, right? How did the Roman Empire fall as part of the demo? Because I didn't want to, I knew you'd be short on time. Okay. And it responded with the hybrid retriever. Okay. Now I can say, when did the empire decline? Okay. And it knows that with the conversation history, with the chat history that's being maintained, I'm referring to the Roman Empire and not any other empire. Okay, and you will see that it processes it, and Byzantine Empire is another Roman Empire, and it talks about when it declined. Okay, and then if I were to say who was Augustus' successor, okay, this is really the graph DB that's being queried, just the graph DB, right? You'll see who is the successor of Augustus. It was Tiberius. Okay, now I'll show you the hybrid retrieval in action. What is hybrid retrieval? It's combining both the graph DB as well as the vector DB. So the query that I have is, what were Augustus' accomplishments? Augustus' accomplishments. Okay, so it knows it needs to look up Augustus and then figure out what Augustus' accomplishments were. Okay, so it figured out that Augustus was also known as Octavian. Okay, this came in from the knowledge graph. Okay, and then it pulled in the vector search, right? It pulls in all this information from as part of the vector search. Okay, so you can see that hybrid retrieval with GraphDB as well as with vector search is working for this query effectively, for the search query effectively. I had another query that I wanted to demonstrate, which was, what were Augustus' accomplishments? What led okay, when did he become emperor? When did he become emperor? By the way, Augustus was the first Roman emperor. I know that because I read the Wikipedia article. So when did he become emperor? Okay, so this is another example where the hybrid retrieval is working, because within the Wikipedia article, it says in 27 BC, the Senate gave Octavian, his previous name, the title of Augustus, right? So it doesn't explicitly, with vector search, you wouldn't have gotten the 27 BC. You wouldn't have gotten this response. This was inferred from the graph DB. Okay, all right, because of entity extraction, relationship extraction. And I've included that particular information in the slide in depth. Feel free to look at it in the slides as well as to how the hybrid retrieval was working for this specific query. Okay, all right. So this wraps up at least the demo pieces of it. And then wrapping up with the slides, I think we just had the applications to cover. And with the applications, the last slide that I had was where do you go from here? I think I've already spoken about this, and I'm going to go back to my Google Chrome. Okay, here we go. So the last section here that I wanted to talk about was cancel, was essentially the last slide. Okay, let's go back to the slides. All right, always the time pressure. There we go. The real world applications. I mentioned identity graphs from my own usage. I've spoken about the identity domain, identity access management and governance. Okay, you can use a graph DB. Okay, then you can also use graph RAG applications within customer support and cybersecurity, manufacturing, supply chain, and also in your agentic AI apps, right? Remember, your agentic AI app is using is using tools, and your tools could use a graph rag as a retriever. Okay, so keep that in mind that it's not just enhancing the RAG, it's not just enhancing an AI search capability. You can also use this within an agentic AI application. I just wanted to wrap with that and call this session as done. We have some Q&As, but I'll leave it to Rohan. Rohan, do you think we have time for questions?
Hey, Dipti,
Rohan,
can
do
you
you
hear me?
think we have time? Yes, I can. Can you
Yeah,
hear
yeah,
me
we
as well?
can. I think we can take a few questions. There are a lot of questions that come in the chat. I was saying like definitely when these sorts of questions comes in, it's definitely means we're doing something good because those questions were around follow-up questions and not like that things are not clear to them. At least that's what my gauge was. I think if you could share the GitHub link again, if it's a shareable link, I don't know, it's your personal link. I saw the name mentioned the link. If it can be shared, can be shared in the chat? It's in the deck. I wasn't sure if I'm supposed to share it, hence I've been nudging you for that.
Oh, no
Um,
worries.
so folks, if there are any questions that you have, any things, we'll be happy to pick things for another 4, 5 minutes.
Okay, I'm going to quickly share the GitHub repo in the chat.
So
Um,
I'll call out one very simple thing. I'm repeating it. I'm so sorry. One is on the slides. We will definitely share the slides. Give me like a day or so, because there's somebody else who manages the community and all. We'll share the slides over there. That is one. Second is in terms of the recordings, we do tend to repeat these sessions once or twice live. After that, we end up sharing the recordings with the folks. Recordings will come to you through the community links first. I'm happy to share the community links if you haven't joined. If you have joined it, great. It will come through your email as well. But initially, first access would be through community. Cool. I think there's some questions coming through your way, Dipti. Feel free to pick those up.
yeah. Um, Folks, I'll start with some of those questions where I feel it's better to outline what's the difference between RAG versus XYZ concepts, right? So I'll pick those questions for now. Okay. So I'll start with one. How is RAG different from reinforcement learning? Okay. Can it be used live in dynamic system? Let me address the first piece of it. So RAG is not the same as reinforcement learning. Okay. So when I spoke about closed models, closed LLM models, right, where GPT-4o mini in the demo that you saw, that was we interacted with it using an API. Okay, that's a closed model. And we are assuming, why is it closed? Because ChatGPT is not revealing what are the weights. Now, LLMs, um, by the way, we teach these in our IK classes. I teach them all the time as part of the advanced ML course. But giving you a very, very brief answer. There's a lot of layers involved, so please keep that in mind. When we work with closed models, these are neural network models. And with neural network models, there are weights. The models are being trained. They are being trained on massive amounts of data, and those weights are not shared. And hence, it's called as a closed model. Okay, ChatGPT doesn't share the weights. However, you have open source models. The ones that I've extensively worked with is Llama, because I find that it's really good at working with Q&A, question answer pairs, which is what we need for search. Okay, and even with training such a model, right? Someone has already done the work for you. So Lava has already done that initial, what's called pre-training, right? It's used massive amounts of data and it's pre-trained that model. Now, once it's being pre-trained, it's also being fine-tuned on instruction question answer pairs. That's called instruction fine-tuning. Okay. There's also classification fine-tuning, and I'm not talking about that. Okay. So keep in mind this has multiple layers. I'm trying to be as brief as possible. You can, once a model has been fine-tuned, right? You can also tune it further, okay? Not just on instruction pairs, question answer pairs. You can tune it further on for human alignment, right? On good answers versus bad answers. That's pretty much what reinforcement learning falls into. You're training it for what humans would want, right? Humans would prefer as your response, as your answer to a question, right? What is a good answer versus what is a bad answer? And that's where you have reward models, you have different techniques for reinforcement learning. I don't want to overwhelm you, but for reinforcement learning, the most prominent technique that's there today, it's called direct preference optimization. It combines reward model together with penalties, right? Penalties is you're penalizing the model for giving you bad answers that a human wouldn't align with a human. Okay, so that's reinforcement learning in a nutshell, and where it falls in this huge training of a closed model versus an open model, right? So with closed models, when you work with OpenAI models, you're assuming that they have been reinforced, they've been fine-tuned on on question answer pairs, and it has also gone through some reinforcement learning. Okay, so we are making that assumption, but in reality, we don't know. Hence, I tend to work with open models where I know exactly what I get and what I need to put in. If I need to fine tune further, I know how to go about doing that as well. Okay, so hopefully that answered what is RAG versus reinforcement learning. I saw another question, which was also some of it was also concept-based learning. Okay, I think we had a question from Harish in here. What is chain of thought and reasoning models? How do they compare with knowledge graph? Okay, so this is again another conceptual question. Now, when knowledge graphs are nothing but it's working with structured data. Its primary purpose is to augment the query in a search to give you a more coherent and a factually correct response. Okay. However, chain of thought and reasoning, these are used pretty much where you want a model to outline how is it solving a given problem, right? What are its intermediate steps? If you're asking it to compute 2 plus 3 times 5, you want it to first do 2 plus 3 times 5 as a second step. That is chain of thought. You wanted to outline your intermediate steps. Reasoning models. This is where you have, remember, I spoke about AI agents and I spoke about tools as one of the components that the AI agents use. AI agents also tend to use reasoning and planning. That's where you have the chain of thought and reasoning patterns, the react patterns, the chain of thought patterns coming in. Now, chain of thought is it used to do great, but now React has taken over, which goes one step. above the chain of thought pattern. Okay, it's not the same as knowledge graph. I think that's the point that I wanted to get across. Okay, all right. Then I'm sorry, I'm going to pick some of these concept-based questions um, on topic. If your question is not answered, my apologies. We are short on time. Okay. Let's see.
I'll
Oh,
genuinely ask you, I'll just jump in and ask you how many more minutes can you give us? We don't want to be like a big, like asking too much of you. But I would say like from the audience perspective, there are too many questions. I'll say if we can take two more, that would be super helpful, and then we can wrap it up.
awesome.
I hope your
That
time
works
allows
great
that.
for me.
Cool.
Thank you, folks. Thank you, folks. Thank you. So let me take two other questions. I'm gonna pick. I'm gonna pick. Okay. Sorry about this. No bias here. But Kader, I think you had a question that says, does a knowledge graph only allow one-to-one entity relationship or any complex relationships like one to many or many to many? Kader, that's a great question, right? And from what I've seen, take the case of Albert Einstein's example that I gave you, right? It was a one-to-one relationship with the other entity. Okay. And knowledge graphs are great at modeling these one-to-one entity relationships. Okay. If there is multiple, then you would want to have multiple hops, right? Because the other example that I gave with the GoodRx's account IDs that I was working with, right? Dipti could have an account ID at the time she browsed the price and the coupon page. At the time she signed up an account, another ID, right? You can think of Dipti having a one is to many relationship with all of these entities, with all of these IDs, right? But we didn't model it. We didn't model the graph that way. We modeled it as Dipti first name and last. The P has a first name and last name, one-to-one relationship. From the first name, last name, working backwards, she has a person ID, right? That was one. That was the most common identifier. From person ID, she has from the person ID, I can resolve to another ID. Let's say ID two, using so and so relationship. So all one-to-one entity relationship. Short answer to your question. Hopefully that clarifies. Uh, Divakaran, with what are the other tools similar to Neo4j? I mentioned AWS Neptune. Yeah, AWS Neptune is another managed graph database. And I've used it in the context of the fractional CTO engagement that I did back in May, June of this year. I constructed a graph neural network model on customer relationship management records, all HRM records, right? Essentially, all your personal records to create to create a unique identity for you. And this was done. I trained a graph neural network, and then I stored it in AWS Neptune. AWS Neptune has its own query language, Gremlin, right? It's not that Neo4j's query language can be used with AWS Neptune. Both of them have their own. These are two different knowledge graph databases with their own query tools. This is what I am familiar with. I don't know if there are others in the market, but these are the ones that are most popular. Hopefully that helped. Okay, so I think I've answered this. I'll take one more last question, and we'll see which one. So Ryan, you had asked. You outlined the benefits of graph connections really well, but what are the downsides compared to using a graph-based approach? I imagine there might be trade-offs around latency, token usage, and the complexity of managing relationships across dynamic data sources. Yes, you're spot on there, Ryan. So the complexity with a graph database is with the amount of data that you have, figuring out what are the nodes that you want to capture in the graph, what are the most important nodes, because you don't want noise to be modeled in your knowledge graph, right? You don't want to pull in unrelated information. Okay, and you need to pick the most important relationships and nodes that directly influence or enhance the outcome of your retrieval. I'm coming back to that outcomes, right? What what influences the outcomes of your retrieval while keeping the graph size small? Why is the graph size? Why should the graph size be small? Remember the latency constraint because you're traversing that query, the graph in real time. Okay, so these are some of the trade-offs. It's not about relationships across dynamic data sources. It's about how you go about constructing a graph where the main goal, what is the outcome that you're looking for? You need to improve the context, the retrieved context that's coming in from whatever vector DB is coming, it gives you. It's not enough, right? The retrieved context is not, it's not pulling in all the structured information that a graph DB would give you. But what are the trade-offs here? Graphs need to be traversed. You need to keep the graphs really, really small and in such a way that you're improving your retrieval, right? That is your end goal. So hopefully I helped outline some of the gotchas and the challenges there. Okay, with this, I think our Q&As, we can conclude our Q&As and I'll pass it off to Rohan. Thank you all. Hope you had a good learning session, a lot of depth, and hopefully I was able to do some justice to it and you walk away with some good value added outcomes. Okay, and look forward to seeing you all in some of the IK classes. Over to you, Rohan.
Nothing more from me, I think. Thank you so much, Zikri, for taking this up. Really appreciate it. Folks, thank you so much for tuning in. It was like a really engaging session. I was seeing the chat, I was seeing the Q&As, and Deepti, thank you so much for addressing most of the questions. I can understand it's not possible to address everything, but you took really great pauses in between. You took your time to address most of the questions people had asked both through chat and Q&A. Thank you so much for being so patient and walking them through the entire session. Thank you, folks. Thank you so much for joining in.